Alright, today we're going to go over exponent rules, including negative exponents and zero exponents. So we'll quickly recap our exponent rules. Our first rule would be if we're multiplying two numbers that have the same base, one way we could simplify them is by leaving the base and adding the two exponents together. Okay? So example of this would be, let's say we had 5 to the power of 2 times 5 to the power of 3. Instead of actually solving both of those and multiplying, we could just leave it as base 5. What is 2 plus 3? So we have base 5 to the power of 5. Okay? And then we could just solve that part. Simple rule, we already know. Second rule I want you guys to remember is if we're dividing exponents with the same base. Okay? We would leave the base the same again. And instead of adding, we do what? Subtract the exponents. So let's use those same numbers. Let's say we have 5 to the power of 3 divided by 5 to the power of 2. That's the equivalent of 5, 3, subtract 2. We always do the one on top from the one on bottom. We're left with 5 to the power of 1. And finally, there is the power of a power rule, where we have a base to some exponent that's to another power. But we leave the same base and we multiply the two exponents by each other. Okay? Example of this would be 5 to the power of 2 to the power of 3 would be written as base 2 times 3, which gives us 5 to the power of 6. A little different than when we added them together. Okay? These are rules you guys went over previously. We're going to add two rules to them. Okay? We're going to talk about, first of all, zero exponents. Zero exponents. So any number to the power of 0. So let's actually number these rules. We'll call this rule 1. This was rule 2. Rule 3. Rule 4. Any number to the power of 0. Anyone know what it equals?
0.
Nope. 1. Every number. Okay. So whether that's 5 to the power of 0, or we have whatever that is, 1,000,000 to the power of 0, still equal to 1. Okay? Pretty simple concept. Anything to the power of 0 is 1. Done. Okay. Fifth rule. This one's a little trickier. What it is say we have an exponent to we have a base that's to a negative exponent. We usually want to work with positive exponents. So in other words, we can make this a positive exponent by flipping this. Now imagine this is technically a fraction. How can it make a whole number a fraction? What do I got to put it over? I put it over 1, right? It's still the exact same number. Dividing anything by 1 will keep it the exact same. So to turn this into a positive exponent, think of it like we're flipping the fraction. So a positive exponent would say 1 over x to be positive a. So we've now turned that exponent into a positive value. Okay? So an example of that would be, let's say we had 5 to the power of negative 2. Well, if I want to make that a positive exponent, that would be 1 over 5 to the power of 2. I don't know why you always do that. Okay? And then to solve that, what is 5 to the power of 2? Anyone know? 25. So technically this answer would be 1 divided by 25, which is a very small decimal number. Okay? So negative exponents, to make positive, think of it like flipping a fraction. And we get the same exponent value, it just would be positive on the bottom. Okay? So we'll go into a couple of examples like this. Those are a little easy. Okay, we'll go to a new page here. So, example 1. I'm going to get you guys actually to try each of these out. They want you to evaluate these. Okay? So, in order to evaluate, try to evaluate as best you can without a calculator. I'll give you 4 questions, a little bit of time to work on it, and then we'll take them up. So 4 to negative 1. I'm not supposed to say negative 1. Is your first example. 2 is 8 to the 0. Question 3 is negative 2 to the power of negative 3. Question 4 is 2 over 3 to the power of negative 2. And then finally 5 is 0 to the negative 2. All right? Write those questions down. I'm going to give you a minute. Pause this. Okay. I gave you a bit of time. Go through the very first one. 1 to the power of 4. Sorry. 4 to the power of negative 1. It says to evaluate. Okay? They wanted us to evaluate these, so not just make positive. There you go. Okay. First thing we're going to do is turn this into a positive exponent, though. To turn that into a positive exponent, I have 1 over 4 to the power of 1. Well, what is 4 to the power of 1?
4.
Just 4. So I have 1 over 4. I could put it as a decimal of 0.25, but a fraction's fine. That's an acceptable answer. 1 over 4. Okay. Question 2. 8 to the power of 0. What is the rule when we have a 0 exponent?
1.
Got 1. Good. Question 3. Negative 2 to the power of negative 3. Okay, this one's a little trickier. We do want to make this exponent positive. So again, we're going to flip it. We're going to have negative 2 to the power of 3. Now, negative 2 to the power of 3, I actually have to evaluate the bottom of this. Okay, that's the equivalent as saying negative 2 times itself 3 times. Okay, I know it's a bit on an angle there. So we would have 1 over, what is negative 2 times negative 2? Positive 4 times?
Negative 8.
Oh, excuse me. Negative 2 is negative 8. Good. Okay. Now, it's not just the bottom of this being negative, the entire fraction. This is negative 1/8. That's what this answer is. You can apply the negative to the top or bottom of the fraction. It still makes the entire number a negative. Okay. 4. 2 over 3 to the power of negative 2. Okay. Now, this one could seem a little tricky, but technically, I want you to remember, we talked about how these are technically fractions, negative 2 over 1, right? A whole number can be a fraction like that. So all we've done to make the exponent positive is flipped our fraction. Now, in this case, we don't have a 1 on the bottom, we have a 3. So we're going to flip our fraction. Okay. So we'll have 3 over 2 to the power of 2. That's now made this exponent positive. Okay. Now that that exponent is positive, we're going to multiply the two brackets by each other. And when we multiply fractions by each other, top by the top and bottom by the bottom, will give us 9 over 4. Okay. Finally, 0 to the negative 2. Okay. Now this one's a bit tricky. Had this said 0 to the power of 2, that would be just 0 by 0, which is what? Right. But here, what this says, right? Think of it as if it is still a fraction, 0 over 1, right? 0 divided by 1 is still 0, it doesn't change that number. But when we go to flip this to make this positive, it becomes 1 over 0 to the power of 2. Okay. What is 0 to the power of 2?
0.
1 divided by 0. Anyone know?
0.
Not 0. No. It's undefined. We cannot divide a number by 0. If you were to put this in your calculator, you get something, it would probably say error or something like that. But we say this is undefined. I think I spelled that wrong. Yeah, there's an E here. Okay, that would be an undefined answer. Okay, so using those rules, that's how we'd solve these questions on the side.